Okay, hello everybody. I've just finished making a robot arm made out of servos. It's got 6 servos in total. 2 here, 1 here, 1 here, 1 for the wrist action, and 1 to close the clamp. And it's controlled by an Arduino microcontroller. And the input is given through a Nunchuck, which I've hacked. I've chopped off the end and fed it into the inputs of the Arduino. Yeah, I've used some heavy-duty servos here, which is just normal sized servos, and here these are actually 9-gram servos. They're not as powerful, but that's okay because they're further away from. They don't feel too much torque, unlike these ones, which actually feel quite a bit of torque. Yeah, and I've got it powered by 2 power supplies. The first power supply provides enough power just for the Arduino, and the second power supply here, it's actually just like a normal transformer power supply, and that powers all the servos and stuff. Now I've just realized that the Arduino can't provide more than 800 milliamps for the servos, so it ended up shutting itself down. So now I just power the Arduino by itself and the servos on a different power supply. Yeah, that's right, I'm using paper clips as things. Whoa. Oh, okay. Let's see. Okay, so if you can see this, the robot is actually controlled by my Nunchuck. If I put it down, it'll go down. If I push it up, it goes up. I've mapped it onto 1-to-1. Well, no, not exactly 1-to-1, but something similar. I've mapped this axis, the y-axis, onto the arm moving up and down. And if I turn it to the sides, it will turn to the sides. If you can see this. If I turn to the other side, come on to the other side. It's pretty cool. And this joystick here will control this servo here. It's pretty cool. Try get this. Unfortunately, the joystick doesn't have really good resolution, so it ends up being really rattly. Yeah, there we go, that's working. Now to control these secondary functions of the... So yeah, on this, I can control 3 servos. To control the other 3 servos, I have to press the Z button here. You can see it. If I press the Z button down, I'll be able to control the top 3 servos. So there we go. See, if I do this, I can down, up, down, and then if I twist it, it will twist the wrist. And if I twist it, the wrist, it's twisting its wrist. It's pretty cool. And if I go up and down, it's doing its wrist as well. It's pretty good. It's got a lot of noise. I think the accelerometers have got a lot of noise, so it ends up being really shaky, if you can see it. But yeah, you can fix that. I don't know, there's probably some software that'll fix it, but I don't know how to do that. So yeah, and this opens and closes the it's fully open, it's fully closed, fully open. I was gonna pick something up with it, but I realized it's not accurate enough to do that. So yeah, that's my robot arm. And let's go back to the primary controls, which controls the first 3 servos. And if I twist it, there. Oh yeah, I'm going to provide a link down below about all the software I've used. the sketch I've used to control this robot. I've got yeah, just download it. Yeah, I'll just show you the servos I've used later after this with this sketch. The control of the wrist is probably the nicest addition to this robot because it just feels really natural and innovative. You know, just turning your wrist turns it to one side and turning it to the other side turns the wrist on to the other side. And it's just a really good analogy for, you know, turning the wrist of the robot. This is one of my failed attempts to show you the picking up of some matchbox, but it's just not working very well. You know, it's just too inaccurate, unfortunately, and it shakes a lot. I need to find out a way of stopping it shake. Maybe some counterweight or something, but you know, just no time to do that. Yeah, just watch it, it's pretty cool. Yeah, I'm just cheating a little bit here. I'm just giving it a helping hand. The fact that I have to hold the nunchuck with the other hand doesn't really help. You know, just even the slightest amount of change in the nunchuck will result in like the shaking of the robot, which is unfortunate. But you know, yeah, I managed to pick it up, and now I'm just showing you. And pretty soon I'm gonna let it go. There we go, let it go. Almost. I'm gonna let it go now. Yeah. The way I've controlled the Arduino, the servo, sorry, is by actually just directly plugging these little, just push pin thingies into the end of the servos and connecting the other ends. Connecting the other ends to the breadboard. If you can see it, these are all the connections. This is the Arduino Mega clone that I purchased off eBay for like $50. The servos weren't too expensive. They were like, you can get them pretty cheap. These are fake Futurbras servos. I bought like 4. These Tower Pro servos was like $2.50. It's pretty cheap as well. And you know, they had free shipping as a deal, so that was pretty good. Yeah, this is actually a third-party Nunchuck. It's not actually made by Nintendo. It was like $5. It was off eBay as well, so cheap. The reason I decided to use a nunchuck to control this is because you could buy the breakout boards with accelerometers on SparkFun, but they're actually like $10. Pretty expensive, and that's like a single axis, which is actually pretty expensive. So I just decided I would get a nunchuck to control it because it has a 3-axis accelerometer, a couple of buttons, and a joystick in a nice, neat package. There's a problem with using third-party accessories to control well, basically control anything really, because the initiation sequence is different. So you'll have to use a library that supports third-party components. Most of the libraries on the Arduino won't support third-party, but there's a couple of topics which will actually support. There's a couple of topics in the Arduino.cc/forums which will actually support third-party nunchucks. The library I've used, I'll link of it below. That one supports the third-party nunchucks.